5, 4, 3, 2, 1.
Our Brainspace 6.1 release contains many new key features. Our latest release dramatically improves accuracy of investigative decisions, accelerates data analysis, and reduces legal costs. Preserve decision IP with portable learning. Build predictive models with zero extra effort using continuous multimodal learning, then easily transfer those models between datasets, generating nearly instant relevance identification results on new cases without the overhead of searching and filtering for likely responsive documents. Expedite investigations with native file analysis. Quickly identify high-value information by extracting metadata and unstructured text directly from the native documents using native file analysis. This feature can be used to expedite internal corporate investigations without the heavy lifting of a traditional e-discovery processing platform. Focus on what's important with targeted learning. With targeted learning, you can significantly reduce the time required to train predictive models and improve model accuracy by using a focus to only include high-value data in the training process. Optimize supervised learning with CMML insights. Gain a deeper understanding of what's driving your predictive ranks and make faster course corrections to your predictive models. Leverage additional data insights after each training round, including changes to responsive terms, metadata, and introduction of new terms that can significantly impact the accuracy of the model. Optimize supervised learning with CMML insights. Gain a deeper understanding of what's driving your predictive ranks and make faster course corrections to your predictive models. Leverage additional data insights after each training round, including changes to responsive terms, metadata, and introduction of new terms that can significantly impact the accuracy of your model. The first key feature we're going to cover in Brainspace 6.1 is native file analysis. Native file analysis is a new connector that allows Brainspace to build a dataset directly from native files, including some of the more common formats, stored on your local network. In order to do this, we'll go ahead into our administration interface, two connectors, and we'll create a new connector here. Select native and name it, and then choose the base path that is the source directory that contains the native files you'd like to load from your network. We'll browse that path, select the current folder, and then go ahead and create the connector. Once the connector is created, we're ready to go ahead and build a data set using that connector, the same way we would build any data set in Brainspace. Add the new data set. We can associate groups at this level. We can then choose the connector we want to use. Select a source, save and proceed, and then move into the pathing to the native files. So in this case, we're going to go ahead and select the top level folder, and we're going to process all of these subdirectories, each of which is representing a different custodian. We're going to then use the top level directories as names for the sources, so we can use those in Brainspace to filter by the custodian names. We're going to move into the field mapping process. And as you'll notice, Brainspace will automatically select the types for the fields that are going to provide value in the Brainspace visuals. The cluster wheel is one of Brainspace's more notable visuals. You can see here in our current example, we have the entire contents of Wikipedia represented in this visual. At a root level, we've got terms that are a little bit more generic because we're trying to basically sum up what 4.3 million articles looks like in this view. We can use the focus, which is essentially a subset, a new wheel built on a subset of data in Brainspace. And in this example, we'll use the term Apollo. So we can see here now the new subset, or the new cluster wheel that we've built, our focus, shows much more meaningful terms because we're really trying to represent a much smaller set of data. We use the same mechanism to isolate and only use and train a subset of documents within a data set. Brainspace 6.1 also introduces targeted learning. With targeted learning, you can significantly reduce the time required to train predictive models and improve model accuracy by using a focus or subset to only include high-value data in the training process. Creating a targeted learning CMML classifier is just like creating a regular classifier. The difference being that you will have an option to select
the focus that you'd like to use for that classifier. And as you'll notice, our Apollo focus is available for us. So that means that only the documents in that focus or subset will be used for training and will be assigned a rank. Brainspace 6.1 introduces portable learning. Portable learning can be achieved using portable models, which can be created from an existing classifier at any round in that classifier, or manually by creating a CSV file that contains the terms and weights that you'd like to apply to the dataset that you're targeting. Portable models can be added to the Brainspace interface and available for any datasets upon creation, or they can be exported or imported via the CSV file format. To modify a model, you can open the CSV, add terms, and adjust weights as needed to achieve the results that you desire. Applying a portable model is as simple as creating a new classifier. In this example, we'll use a pre-built portable model built on lunar craters. We'll select our positive and negative values and simply import the model from either your drive or choose an existing model from your model library. Once you click Save, the model will start going through the dataset and assigning appropriate ranks based on the model. Once the classifier is built and the model has been applied, you'll notice that our sorting will have documents that scored higher based on our model at the top of the pile. All the documents we're looking at here are articles that mention terminology around lunar craters.
Another key feature we've added in Brainspace 6.1 is the ability to view your dashboard and other visuals in the context of a CMML classifier. You'll notice next to the drop-down where you'd select a focus, the ability to also select a CMML classifier. Once you select a classifier, the interface will then adjust to the sorting of that classifier rank. You'll see here on the top right-hand corner in your document list, instead of a hit relevance, you now have the predictive rank histogram, and you can use the trim functions as you would in the supervised learning interface. The other thing we've also added is the ability to move between the traditional supervised learning interface where you select training rounds and the standard analytics view. We've also added the ability to use CMML classifiers within notebooks to sort by the rank of that given classifier. When you go to create a new classifier, you'll now notice that in addition to using tags with a specific notebook, you can also use the classifier. Once you've assigned a classifier to a notebook, you can then execute a search that'll take you to the dashboard. You'll be sorted within the notebook results in the order of that classifier's rank. When you're in the notebook that you've just created using a classifier, select the classifier that you'd like to use. You can associate more than one with a notebook. And then when you click on the search button from the notebook, it will take you to the dashboard and you will be looking at the contents of that notebook sorted by the classifier that you choose. Another feature that we've added in 6.1 is the ability to create batch notebooks from a classifier, distributing the results by score or rank. The way this feature works is from supervised learning, you select a notebook, you create batch notebooks, select a prefix for the notebooks that you're going to generate. We'll just use T for test. Set the score range, so we'll go ahead and create a notebook that ranges from 0.4 to 0.7, and the number of notebooks that you'd like to generate. Brainspace will automatically distribute the document counts across the score range. As you can see, we now have a distribution of document counts based on the score range. Brainspace 6.1 has added the ability to now schedule a sync of a notebook to a third-party platform tag. You select the field that you'd like to sync the notebook to and the value. And now when you connect, you get the option to toggle whether you want to pull or push the data, and this change button appears.
This allows you to schedule a one-time sync for a time of your choice, or to set a recurring schedule daily, twice daily, or weekly. And you can also choose the time and date that the first run kicks off. Brainspace 6.1 has also improved the term heat map by allowing you to select multiple cells and add those to your search. You can do it for both document volume and anomaly detection. It's as simple as selecting multiple cells after you've moved the toggle and then adding them to your search. Brainspace has now added the ability to push connected tags to a third-party integration. If we haven't already connected a tag, we'll go ahead and do that now. We're going to go ahead and connect the CSBS test tag. Once that tag is connected in Brainspace, the decisions that have been made on the Brainspace side can now be pushed to Relativity or other third-party integrations. We'll give you a warning to make sure that if that field is populated in Relativity, that you have to consider that you will be overwriting those values. Brainspace has also added the ability to see the different types of attachments in calendar documents indicated in the search results panel. Brainspace has also added a login message or disclaimer that can now be presented when a user logs in via configuration in the Brainspace properties. 6.1 also introduces support for Chinese email headers.